If Earth moved just 3% closer to the sun, every ocean would boil away in less than 1 billion years. If it drifted just 15% farther, you'd be breathing frozen air right now. Think about this. You're floating on a rock that's positioned with the precision of a Swiss watchmaker, 93 million miles from a nuclear furnace that's been burning perfectly for 4.6 billion years. That's not just lucky. That's mathematically impossible. But here's the real mystery. Earth isn't just perfectly placed. It's perfectly everything. The perfect atmosphere, the perfect moon, the perfect magnetic field, even the perfect chemical recipe for consciousness itself. Tonight, you'll discover 15 cosmic coincidences so precise that some of the world's top scientists are quietly whispering about design. After this journey, you'll never look at your morning coffee the same way again, because you'll know just how many impossible things had to align perfectly for that simple moment to exist. So settle in, let the night embrace you, and prepare to drift through the most profound question humanity has ever asked. Welcome to another night of cosmic mysteries where the universe's deepest secrets become the most soothing bedtime stories. So take a deep breath, let your mind settle, and allow me to paint you a picture of the most extraordinary cosmic ballet ever performed. Picture this. You're floating in the infinite darkness of space, surrounded by billions of stellar furnaces, each one burning at temperatures that would vaporize anything we know. Most of these cosmic giants are orbited by dead worlds, planets either frozen solid or melting into gas, silent worlds where the very concept of a flower, a raindrop, or a gentle breeze is impossible. But then there's Earth positioned at exactly 93 million miles from our sun. Not 92 million, not 94 million, exactly 93 million miles. This isn't just a number. It's the most crucial measurement in the history of life itself. Before we dive deeper into this cosmic precision, I'd love if you could take just a moment to subscribe and give this video a gentle like, but only if it truly resonates with you. And I'm curious, where are you right now as you listen to this? Are you tucked under warm blankets, perhaps watching the shadows dance on your ceiling? Leave a comment and let me know your cozy corner of the world. You see, our sun isn't just any ordinary star. It's what scientists call a G-type main sequence star. Stable, steady, burning hydrogen into helium at precisely the right rate for over 4.6 billion years. Most stars in our galaxy are cosmic misfits, red giants that expand and contract unpredictably, blue supergiants that burn out in mere millions of years, or white dwarfs that barely whisper heat into the void. But our sun, it's been the perfect cosmic hearth, warming Earth with the consistency of a loving parent for eons. That magical 93 million mile distance creates what astronomers call the Goldilocks Zone. Not too hot, not too cold, but just right. This habitable zone around our sun extends roughly from 91 to 94 million miles. Earth sits almost precisely in the center like a perfectly tuned note in a cosmic symphony. Here's where the precision becomes almost unbelievably strange. Venus, our planetary neighbor, sits just 25 million miles closer to the sun. In cosmic terms, that's like moving your chair 2 in closer to a campfire. Yet this tiny adjustment has transformed Venus into a hellscape where lead melts on the surface, where atmospheric pressure would crush your body instantly, and where sulfuric acid rains from poisonous clouds. Surface temperature, a toasty 900 degrees F, hot enough to bake a pizza in seconds. Mars tells the opposite story, sitting only 42 million miles farther from the sun than Earth. Again, like stepping 2 in back from that same campfire, Mars has become a frozen wasteland where the average temperature is 80 degrees F. Its atmosphere is so thin that your blood would literally boil if you stepped outside without protection. Massive dust storms rage for months, covering the entire planet in rusty darkness. These aren't small differences. These are the differences between paradise and perdition, between worlds where children play in meadows and worlds where existence itself is impossible. But here's where Earth's story becomes even more miraculous. Recent discoveries reveal that planets don't always stay where they're born. Jupiter, our solar system's giant guardian, likely migrated inward toward the sun during our system's chaotic youth, then migrated back outward in a cosmic dance that could have easily swept Earth into the sun or flung it into eternal darkness. Yet somehow, through billions of years of gravitational choreography, Earth maintained its perfect position. Dr. Hugh Ross, a renowned astrophysicist, has calculated the probability of a planet naturally occurring in such a perfect orbital position, approximately 1 in 10 to the 15th power. To put that in perspective, imagine randomly throwing a dart at a dartboard the size of North America and hitting a bullseye the size of a coin blindfolded while riding a roller coaster in a hurricane. This perfect distance creates more than just comfortable temperatures. It enables liquid water to exist stably on our surface. Water, that magical substance comprising 60% of your body right now, can only exist as a liquid within an incredibly narrow temperature range. Too hot and it becomes steam, escaping into space forever. Too cold and it freezes solid, locking away the essence of life itself. Across the cosmos, liquid water is breathtakingly rare. Most water exists as ice on frozen moons or vapor in the atmospheres of distant gas giants. But Earth? We have vast oceans of liquid water, gentle lakes, flowing rivers, and soft rain that nourishes every living thing. All because we occupy that perfect sweet spot where the sun's warmth touches us with precisely the right intensity. As you rest there tonight, feeling the perfect temperature of your room, breathing air that's neither too warm nor too cool, you're experiencing the extraordinary result of cosmic precision. You exist because of a distance, a measurement, a coordinate in space that has remained stable for over 4 billion years, allowing not just life to emerge, but consciousness itself to evolve and contemplate its own miraculous existence. Some scientists argue this is cosmic lottery luck. That in a universe containing hundreds of billions of galaxies, each with hundreds of billions of stars, statistical probability virtually guarantees that perfect conditions would arise somewhere. They call this the anthropic principle. We observe a universe fine-tuned for life simply because we're here to observe it. But others examine the mathematical precision and whisper about intentional design, about a cosmic architect who positioned Earth with the meticulous care of a master craftsman, knowing that this exact distance would nurture beings capable of wonder, love, dreams, and profound questions about their own existence. What do you think? As you drift towards sleep tonight, consider this. Are we riding a planet positioned by pure chance, or are we floating through space at coordinates chosen with infinite precision? Leave your thoughts in the comments. I genuinely love hearing your perspectives on these cosmic mysteries. Narrator, VO. Tonight, as sleep begins to embrace you, you're traveling through space at exactly 93 million miles from a perfect star. Narrator, VO. You're aboard a world that has maintained this precise distance, longer than mountains have stood, longer than oceans have flowed, longer than any life form has drawn breath. Narrator, VO. And tomorrow when you wake, Earth will still be here, still perfectly positioned, still maintaining the cosmic coordinates that make your morning coffee, your gentle thoughts, and your beating heart possible. Narrator, VO. But Earth's perfect distance is merely the opening movement in a symphony of impossible precision. As we drift deeper into this cosmic mystery, we'll discover how our celestial companion, the Moon, performs an ancient gentle dance that stabilizes our entire world, creating rhythms that govern not just ocean tides, but the very pulse of life itself. Narrator, VO. Now, let's drift into one of the most romantic cosmic relationships ever discovered, the eternal dance between Earth and our Moon. Imagine this. Without our Moon, you wouldn't be here tonight. Not just metaphorically, literally. Earth would be spinning wildly through space like a cosmic top, losing its balance, experiencing temperature swings so extreme that one day might last just 6 hours, while seasons would shift chaotically from tropical summers to ice ages within decades. Our planet would be uninhabitable, a world of violent weather and endless instability. But here we are, gently cradled by the Moon's invisible embrace, experiencing what might be the most perfectly choreographed dance in the entire universe. Our Moon is extraordinary in ways that still puzzle astronomers. It's proportionally huge compared to Earth, about 1/4 our planet's diameter. Most moons in our solar system are tiny rocks, captured asteroids that bear no relationship to their host planets. But our Moon, it's so large and so perfectly positioned that some scientists call the Earth-Moon system a double planet rather than a planet and its satellite. This cosmic partnership began 4.5 billion years ago in what scientists call the giant impact hypothesis. A Mars-sized object, astronomers have named it Theia, collided with the early Earth in a cataclysmic event that ejected massive amounts of material into orbit. Over millions of years, this debris slowly coalesced into our moon. But here's the miraculous part. This collision had to be perfect. Too direct, and both objects would have been destroyed. Too glancing, and the debris would have scattered into space. The angle, speed, and timing had to be precisely calibrated to create our lunar companion. What are the odds of such a perfect collision? Dr. Robin Kupe from the Southwest Research Institute has calculated that the probability is roughly 1 in 100, and that's assuming the collision happened at all. The chances of it happening with exactly the right parameters to create a stabilizing moon astronomically small. But let's explore what this gentle giant actually does for us. First, our moon acts like a cosmic gyroscope, stabilizing Earth's axial tilt at approximately 23.5 degrees. This might sound like technical jargon, but it's actually the foundation of all life as we know it. Without this stabilization, Earth's tilt could vary wildly from 0 to 85 degrees over thousands of years. Picture a world where the tilt shifts dramatically. The North Pole could suddenly point directly at the sun, creating summers where the Arctic reaches 200 degrees F while the equator freezes solid. Then, as the tilt shifts again, these extreme conditions would reverse. No ecosystem could survive such chaos. No complex life could evolve. No gentle seasons could nurture the slow development of forests, rivers, or the intricate web of life that surrounds us. Mars offers us a haunting glimpse of this instability. Without a large stabilizing moon, Mars experiences tilt variations of up to 60 degrees over periods of about 2 million years. This creates climate chaos that prevents any stable atmosphere or consistent surface conditions. Mars is essentially a world in perpetual environmental crisis. But Earth, our moon, keeps us steady, creating the predictable seasons that have allowed life to flourish for billions of years. Spring follows winter with reliable precision. Ocean currents flow in stable patterns. Weather systems develop predictably, all because our moon gently holds us in cosmic balance. The moon also gifts us with tides. And these aren't just pretty phenomena to watch from the beach. Tides may have been crucial for the origin of life itself. In the shallow tidal pools of ancient Earth, organic molecules were repeatedly concentrated and mixed as waters retreated and returned. This natural laboratory provided the perfect conditions for the chemical reactions that eventually sparked life. Dr. Richard Ley, a molecular biologist, argues that without tidal mixing, the complex chemistry necessary for life might never have developed. The moon essentially became Earth's first chemistry set, creating billions of natural experiments in tidal pools across the planet for hundreds of millions of years. And here's something that might surprise you. Our moon is slowly moving away from us. Every year, it drifts about 1.5 and farther from Earth. This means that in the distant past, it was much closer, creating tides hundreds of feet high. These massive tides would have mixed the early oceans thoroughly, distributing nutrients and organic compounds across vast distances, essentially preparing Earth for the emergence of life. But the moon's distance isn't just gradually changing, it's changing at exactly the right rate. If it were moving away too quickly, we would have lost tidal mixing before life could establish itself. If it were moving away too slowly, the massive tides would continue today, making coastal life impossible. Instead, it's moving away at precisely the rate that allowed life to emerge and then stabilize as conditions became gentler. Consider also the moon's role in our planet's rotation. Without lunar influence, Earth would spin much faster. A day might last only about 6 to 8 hours. Think about how this would transform everything. Weather patterns would be chaotic with massive temperature swings between the short days and nights. Plant life couldn't adapt to such rapid cycles. The development of complex ecosystems would be nearly impossible. But perhaps most remarkably, our moon creates what astronomers call tidal locking effects that have profound implications for life. While the moon isn't tidally locked to Earth in terms of rotation, its gravitational influence has gradually slowed Earth's rotation to a stable 24-hour cycle that seems almost perfectly designed for biological rhythms. Every living thing on Earth, from the smallest bacteria to the largest mammals, operates on circadian rhythms that closely match our 24-hour day. Plants open and close their leaves in daily cycles. Animals sleep and wake in patterns synchronized to daylight. Even your own body temperature, hormone production, and cellular repair processes follow this lunar-influenced rhythm. Scientists have discovered that when humans are isolated from all time cues, their natural circadian rhythm runs approximately 24.2 hours, remarkably close to Earth's actual day length. It's as if our biology was designed around the moon's influence on our planet's rotation. The moon also creates what's known as the lunar month, approximately 29.5 days, which has influenced biological cycles throughout Earth's history. Many marine organisms time their reproduction to lunar cycles. Some coral species spawn only during specific moon phases. Women's menstrual cycles average about 28 days, strikingly close to the lunar month. These connections suggest that life on Earth has evolved in intimate harmony with our moon's presence. From an astronomical perspective, our moon is an anomaly that shouldn't exist. Most planets either have no moons, tiny captured asteroids, or in the case of gas giants, dozens of small moons captured from the debris of the early solar system. But a terrestrial planet with a single large, perfectly positioned moon that stabilizes its climate and enables life. This appears to be extraordinarily rare. As you lie there tonight, perhaps you can sense the moon's gentle pull. It's tugging on every drop of water in your body. The same gravitational force that moves our oceans is moving through you right now. You are literally dancing with the moon, participating in a cosmic ballet that has been performing for over 4 billion years. As you lie there tonight, perhaps you can sense the moon's gentle pull. It's tugging on every drop of water in your body. The same gravitational force that moves our oceans is moving through you right now. You are literally dancing with the moon, participating in a cosmic ballet that has been performing for over 4 billion years. What do you think about this cosmic partnership? Does the precision of the Earth-Moon relationship suggest random chance or something more intentional? I'd love to hear your thoughts about whether you feel connected to lunar cycles in your own life. Share your experiences in the comments below. Tonight, as you drift towards sleep, you're being gently rocked by gravitational forces that have cradled every generation of life on Earth. The same moon that creates our tides, stabilizes our seasons, and regulates our days is watching over you right now, continuing its ancient dance that makes consciousness, dreams, and peaceful sleep possible. But our moon is just one member of Earth's protective family. Next, we'll discover an invisible shield that surrounds our planet. A magnetic barrier so powerful and so perfectly calibrated that it guards every breath you take from deadly cosmic radiation that would otherwise strip away our atmosphere and sterilize our world. Right now, as you rest comfortably in your bed, you're being bombarded by deadly radiation from space. Cosmic rays traveling at nearly the speed of light. Solar wind particles carrying enough energy to strip atoms apart, and gamma radiation that could cook your DNA in minutes. Yet here you are alive, breathing completely unharmed. How is this possible? The answer lies in one of Earth's most remarkable and invisible guardians, our planet's magnetic field. It's a force so powerful it deflects particles traveling at 1,000 kilometers per s, yet so gentle you can't even feel it. And without this invisible shield, Earth would look exactly like Mars. A barren, radiation-scorched wasteland where life never had a chance. Let me paint you a picture of just how hostile space really is. Every second, our sun hurls billions of tons of charged particles into the solar system at speeds exceeding 400 kilometers per s. This solar wind carries enough energy to power human civilization for millions of years. And that's just from our own star. Beyond our solar system, cosmic rays, the remnants of exploded stars, streak through space with energies so intense they can penetrate several feet of lead. To put this in perspective, astronauts on the International Space Station, just 250 m above Earth's surface, receive radiation doses equivalent to getting 8 chest X-rays every single day. During their 6-month missions, they accumulate radiation exposure equal to what you'd experience from 100 chest X-rays, and they're still partially protected by Earth's magnetic field. Imagine what unshielded exposure would do. Mars tells us exactly what happens to a planet without magnetic protection. NASA's MAVEN spacecraft has discovered that Mars loses about 100 g of its atmosphere to space every single second due to solar wind stripping. That might not sound like much, but over geological time, this has transformed Mars from a world with a thick atmosphere and flowing rivers into the thin-air desert we see today. Dr. Bruce Jakosky, principal investigator for the MAVEN mission, estimates that Mars has lost 99% of its original atmosphere to space, blown away by solar wind because it lacks a global magnetic field strong enough to protect it. Earth could have suffered the same fate. But something extraordinary happened in our planet's core. Deep beneath your feet, about 1,800 miles down, lies one of the most remarkable dynamos in the known universe. Earth's outer core is a churning ocean of liquid iron and nickel, heated to temperatures exceeding 4,000 degrees C, as hot as the sun's surface. This molten metal flows in complex patterns driven by the planet's rotation and convection currents, creating electrical currents that generate our magnetic field. This process, called the geodynamo, is incredibly complex and delicate. The liquid iron must be at exactly the right temperature. Too cool, and it solidifies. Too hot, and the convection patterns break down. The planet's rotation must be at precisely the right speed to create the Coriolis forces that organize the flow. The core's composition must have exactly the right ratio of iron to nickel and other elements. What are the odds of all these factors aligning perfectly? Planetary scientists estimate that fewer than 1 in 1,000 rocky planets develop and maintain a strong, stable magnetic field like Earth's. Most planets either never develop one or lose it as their cores cool and solidify. Exactly what happened to Mars about 4 billion years ago. But Earth's magnetic field isn't just any magnetic field. It's remarkably well designed for protecting life. The field extends far into space, creating a region called the magnetosphere that stretches about 370,000 m toward the Sun and over 1 million miles away from the Sun. This invisible bubble deflects most solar wind particles around Earth, like water flowing around a rock in a stream. Here's where it gets truly extraordinary. Earth's magnetic field has the perfect strength. Too weak, and it wouldn't protect us from radiation. Too strong, and it would trap so much cosmic radiation that it would actually make our planet more dangerous, not less. Our field strength of about 2565 microteslas is precisely calibrated to provide maximum protection, while allowing beneficial cosmic rays to reach our atmosphere, where they help drive atmospheric chemistry and even influence cloud formation. The magnetic field also creates one of nature's most beautiful phenomena, the aurora. When solar particles do manage to penetrate our magnetic defenses, they're channeled toward Earth's poles, where they collide with atmospheric gases and create those breathtaking curtains of light we call the northern and southern lights. It's literally our planet's magnetic field made visible, a cosmic light show that reveals the invisible battle being fought high above us every night. But perhaps most remarkably, Earth's magnetic field has remained stable for over 3.4 billion years. We know this because certain minerals like magnetite align themselves with the magnetic field when they crystallize, creating a fossil record of ancient magnetism locked in rocks. This geological evidence shows that Earth has maintained protective magnetism for most of its history, just long enough for life to evolve from simple bacteria to complex thinking beings. However, our magnetic field isn't perfectly stable. About every 200,000 to 300,000 years, it weakens dramatically and sometimes even reverses completely. Magnetic north becomes magnetic south. During these reversals, which can last anywhere from a few thousand to tens of thousands of years, Earth's magnetic protection drops to as little as 10% of its normal strength. Remarkably, life has survived every single magnetic reversal in Earth's history. Some scientists theorize that these periods of weakened protection might actually drive evolution by increasing mutation rates slightly, providing the genetic variation that allows species to adapt and evolve. It's as if Earth's magnetic field has been calibrated not just to protect life, but to occasionally challenge it in ways that promote growth and diversity. The precision of this system becomes even more astounding when we consider the alternatives. Venus, despite being similar in size to Earth, has virtually no magnetic field because its core doesn't rotate fast enough to generate one. As a result, Venus has lost most of its water to space over geological time. Mars, as we mentioned, lost its magnetic field early in its history when its core cooled and solidified. But Jupiter's moon Europa, despite having no magnetic field of its own, may harbor life beneath its icy surface because it orbits within Jupiter's enormous magnetosphere. the largest magnetic field in our solar system. This suggests that magnetic protection might be absolutely essential for life anywhere in the universe. Dr. Amir Kastbi from the Southwest Research Institute has calculated that without Earth's magnetic field, our atmosphere would be stripped away in just a few million years. The blink of an eye in geological terms. All the water vapor would escape to space. The protective ozone layer would be destroyed, and the surface would be sterilized by radiation. Earth would become another dead world, drifting silently through space. Think about this for a moment. Every breath you're taking right now exists because molten iron is swirling in precise patterns and 800 miles beneath your feet. Every drink of water you've ever taken, every sunset you've watched, every person you've ever loved. All of it is possible because of an invisible force generated by processes so deep underground that we've never directly observed them. As you lie there tonight, you're being protected by a force field that extends hundreds of thousands of miles into space. It's deflecting cosmic radiation that could kill you in minutes, preserving the atmosphere that gives you breath and maintaining the conditions that make dreams, love, and consciousness possible. Have you ever seen the aurora borealis or aurora australis? Those dancing lights are literally our magnetic field at work, protecting us while putting on one of nature's most spectacular shows. If you've never seen them, they're worth adding to your life's adventure list. They're our planet's way of making the invisible visible. But our magnetic shield is just one layer of Earth's protective systems. As we drift deeper into this cosmic mystery, we'll discover how our planet wraps itself in a perfectly calibrated blanket of gases. An atmosphere so precisely tuned that changing even a fraction of its composition would make our world uninhabitable. Take a deep breath. Hold it for a moment. Feel that oxygen flowing into your lungs, your bloodstream, your brain. What you just experienced is one of the most improbable chemical reactions in the universe. And it's happening inside you right now because Earth's atmosphere contains exactly 20.95% oxygen. Not 25%, not 15%, but precisely 20.95%. And that tiny decimal point difference, it's literally the difference between life and instant death. Here's something that will blow your mind. If Earth's atmosphere contained just 25% oxygen instead of our current 21%, you wouldn't be peacefully lying there listening to this. You'd be living on a world where every lightning strike triggers massive forest fires that burn uncontrollably across continents, where a single spark could turn your wooden house into an inferno in seconds, where the slightest friction, like walking across carpet in socks, could literally explode the air around you. Oxygen is beautiful, life-giving, essential, and absolutely deadly in the wrong concentrations. But let's go the other direction. If our atmosphere dropped to just 16% oxygen, you'd be gasping for breath right now, experiencing altitude sickness just lying in your own bed. Your brain would struggle to function. Complex thought would become nearly impossible. The rich diversity of life we see around us simply couldn't exist. So, how did Earth end up with this Goldilocks level of oxygen? The answer takes us back to one of the most dramatic transformations in our planet's history. An event so catastrophic that scientists call it the Great Oxygenation Event. And it nearly destroyed all life on Earth. Picture our planet 2.4 billion years ago. The atmosphere contained virtually no oxygen, just methane, carbon dioxide, and other gases that would suffocate you instantly. The oceans were purple and green, filled with primitive bacteria that had never seen oxygen in their lives. It was an alien world, but it was teeming with microbial life perfectly adapted to an oxygen-free existence. Then something extraordinary happened. A group of bacteria called cyanobacteria evolved the ability to photosynthesize to capture energy from sunlight and split water molecules, releasing oxygen as a waste product. These tiny organisms had no idea they were about to trigger the greatest environmental catastrophe in Earth's history. Dr. Lee Kump from Pennsylvania State University describes this period as the first pollution crisis. For these ancient bacteria, oxygen was toxic waste, a poisonous gas that killed almost everything it touched. As cyanobacteria multiplied and spread across the oceans, they pumped billions of tons of this toxic oxygen into the atmosphere. The result, a mass extinction event that wiped out most life on Earth. Entire ecosystems collapsed. The purple and green bacteria that had dominated the planet for billions of years died in massive numbers, poisoned by the oxygen they couldn't process. It was an apocalypse that lasted nearly 300 million years. But here's where the story becomes miraculous. Instead of sterilizing Earth completely, this oxygen catastrophe created the perfect conditions for an entirely new kind of life. Life that could harness oxygen's incredible energy potential. Organisms that could use oxygen lived about 16 times more efficiently than their oxygen-free ancestors. They could move faster, think more clearly, and evolve into increasingly complex forms. The mathematical precision of how this all balanced out is staggering. Too much oxygen too quickly and the planet would have become a fire-prone wasteland. Too little oxygen and complex life could never have evolved. But the rate of oxygen production, the planet's ability to absorb and regulate it, and the evolution of oxygen-breathing organisms happened in perfect synchronization over hundreds of millions of years. Today, Earth's atmosphere is a masterpiece of chemical engineering. It's 78% nitrogen, an inert gas that provides the perfect dilution for oxygen while remaining completely non-reactive under normal conditions. Without nitrogen, our 21% oxygen would be concentrated enough to turn Earth into a tinderbox. With too much nitrogen, we'd suffocate despite having oxygen present. The remaining 1% of our atmosphere is a precisely calibrated cocktail of trace gases, each playing a crucial role. Argon provides additional inert dilution. Carbon dioxide at just 0.04% creates the perfect amount of greenhouse warming, enough to keep our planet from freezing, but not enough to create a runaway greenhouse effect like Venus. But here's what's truly extraordinary. Our atmosphere isn't just sitting there passively. It's actively maintained by one of the most complex feedback systems ever discovered. Plants consume carbon dioxide and produce oxygen. Animals consume oxygen and produce carbon dioxide. Ocean algae regulate both gases while marine organisms manage the acidity of seawater. Weather patterns distribute these gases globally, while geological processes bury excess carbon and release it over geological timescales. Dr. James Lovelock, the scientist who proposed the Gaia hypothesis, calculated that without active biological regulation, Earth's atmosphere would naturally drift to about 98% carbon dioxide and 2% nitrogen within just a few million years, essentially becoming like Venus. The fact that our atmosphere has remained stable and life-supporting for over 2 billion years suggests an incredibly sophisticated self-regulating system. Consider the pressure of our atmosphere, another coincidence that's absolutely essential for life. At sea level, atmospheric pressure is 14.7 pounds per square inch. This might seem arbitrary, but it's precisely the pressure needed to keep water liquid across the widest possible temperature range. Lower pressure in water would boil at room temperature. Higher pressure in water would remain liquid only under extreme heat conditions. This pressure also allows our lungs to function efficiently. Human lungs evolved to extract oxygen from air at exactly this pressure. At significantly higher pressures, oxygen becomes toxic to our nervous system. At lower pressures, we can't extract enough oxygen to maintain consciousness. Earth's atmospheric pressure sits in the narrow sweet spot where complex oxygen-breathing life can thrive. The atmosphere's layered structure is equally